Hemendra is a verification expert with over 40 years of experience. He worked for IBM, Synopsys, AMD, and many others. He led many projects through the entire verification lifecycle from initial architecture exploration to design implementation to tape out. His projects include CPUs, GPUs, wireless, networking, telecom, solid-state drive, and various peripheral IPs. He's now taken a technical advisory role for various verification tool startups and also worked as a corporate director. And he's going to talk about verification by documentation.
Thank you. Thank you, Mike. All of you have your badges with the QR code, right? So one of the things I want to know, I'm wearing Google glasses that can read your QR code. It conducts voice through my thing and tells me about you. So your name print is so small I can't read, but it tells me what your name is. And it goes and searches the internet and tells me through LinkedIn what you do. And it prompts me what to ask. The only problem is it didn't work this morning, so I called Google and I said, this is a problem. It's an experimental glass and it didn't show up. I said, oh, it's a small bug. It's a firmware bug. We're going to send you the update. And they sent me the update, and the update didn't work either. And then I said, what do I do now? Oh, this is sorry. It's a hardware bug. And imagine this being 1 million copies of it. They have to recall every one of the glasses back. The hardware bugs are expensive, unlike firmware bug or software bug. If you're lucky, you have a software bug. Maybe a firmware bug. It can be fixed. You get an update, you're good. So I'm talking in this presentation a lot of motherhood and apple pie that all of you know enough about. But it's motivated by the first talk that I heard in my first job 35, 40 years back. And my boss gave that presentation. It was called Design by Documentation. And he said that the real issue is the design, the coding is easy. Anybody can do it. The easiest part is coding, but getting it right requires clear thinking. And the clear thinking comes only through documentation process. Unless you have documented it clearly, you haven't thought through clearly. If you don't think through clearly, you can't document. You will postpone it. You will experiment with things. Sometimes it's all right. You can experiment and postpone. So that's the motivation for it. So what I did over time is just went ahead and talked about, let me see how it works. Oh, this one. Okay. Very good. Let's go back. Thank you. So the hardware bugs are expensive and we want to track them. So what I was thinking through is design by documentation philosophy is nothing new about it. Design by verification is also nothing new about it. But it's a problem that I wanted to highlight, shine light on it, only because it still remains a problem. And as we move forward in the future with more automation, it's going to be a bigger problem. So it needs to be solved and it needs attention. And if you look at the documentation cycle, whether you're doing architecture and specification is nothing else but documentation as far as you're concerned. That's the only, what is architecture? It's a piece of documentation that contains all the architected information, whether it's a firmware spec, verification spec, whatever you call it. Implementation is some code, but hopefully well-documented code. And then verification depends on a lot of documentation. So let's quickly look through it. So this is your DUT, and that you're going to verify. And this is your verification flow. So it goes from developing a strategy, creating a plan, putting a flow together, maybe some tools, technology, depending on the approaches you have decided for verification. And then you have some test bench architecture, maybe UVM, maybe System C, maybe some other things. Then you have some verification process, and so on. So that's a very classic thing. So I'm not going to talk about any specific tool per se, but this is very generic in the sense that it applies to almost everyone. There are some adjustments you might make depending on your design. You might be doing something different, but overall, this is the general flow. And each of them depends on some documentation. So you'll have a strategy document, a plan document, a test plan document, maybe your test bench architecture document. You might have a coverage plan and all of this, and then your regression flow might produce more document that you may use. So each and every phase of verification is dependent on documentation. And each documentation has a review process associated with it. And each of these documentation depends on some other documentation, which is from system spec, which actually depends on some requirements, and then architecture firmware spec. All of those feed into other thing. And then if you go up, the design and microarchitecture spec derived from, so left to right, you're deriving and refining the documentation to a better documentation, a more detailed documentation that feeds into your verification process. And each of these phases has a review process associated with it. I kind of lump them into the right side, into one single review, but almost every stage of document, because only way to verify documentation is through rigorous review process. The due diligence is requirement. So if you think the left side is owned by design, the first 3 blocks, the right 3 blocks are owned by design and verification engineers. Both own it. It's a co-ownership. It's not a one person's job. And while the other documents in the lower side is all owned by the verification team, so to say. So this is the general flow, mostly applied to almost every team, if you will. These are the areas. So what I wanted to go through is just highlight the fact that there are bugs to be found at every stage of documentation. And just feel free to participate if you want to, because I don't like Q&A at the end. So if you have a comment, you can make it in the middle if you like. We'll try to manage the time. But the requirements inside the system specs here, these are the places, and I'm talking about the bugs that are expensive. The ones that you caught during things are, there are a lot of advanced tools you have, your planning process, you can, and some we heard today, you have a way to find them. But the ones that you didn't find, that went to the customer, for which a product had to be recalled, where do they lie? And that's where I'm just highlighting it, that the cost of not documenting is very, very expensive. And these are the areas, the point where they might be. And you will see all of these places you have potential for, and all of these bugs I have seen personally on one product or another in my 35 years. And they still show up. We have found a way to do a first time tape out without having to redo it. But at the end of the day, there is a product out there. If you're lucky, you can do a firmware update and get away with it. But we have products that were shipped out 5 years back. They're still finding bugs and we are still fixing it. And if it's a hardware bug, it's expensive. You just have to tell, oh, by the way, you have to disable that feature if you're lucky. Otherwise, you have a bad product if you have to recall. Especially if it goes in any of the edge where it goes into automobile or something, that part is gone completely. It has to be completely recalled and put in back. Very expensive. So these are the 5 or 6 points where bugs are expensive. And so these are, let's just go through all 6 of them just quickly. I want to highlight quickly and we can move on. But feel free to comment if you see anything different. So the requirement documents, specifications, I've clubbed them all together as you saw in the picture. Implementation, verification plan, coverage plan, and reviews. And this is something, again, feel free if you find any disagreement, and it's not a complete picture, it's just a point to highlight where the issues are. The system specs I've seen, this is actually even in the previous current projects also, but I've seen it from almost all projects where there are gaps in the specification, the things are not written properly, and primary reason, there are 2 reasons for it. Either there was a lack of understanding of the spec at the time the specs were done, or there was a pressure of schedule. I have to move fast. I don't have time to document everything. The designer knows, the architect knows. He makes assumptions that the people downstream will know, but that is not the case. So if you look at the hierarchy of people from architect down to the verification engineer, there are various people who may not have the right background to make the same assumption. And so there is a bug in there. So misunderstood by architects, misunderstood by designers. Very, very common. Sometimes it's just written poorly, and this sometimes comes because engineering world is full of people with different competencies in English, and it creeps in how it's specified. The second one that I quickly want to highlight is in the design itself. This is a common problem in the last project itself. We have a lot of legacy specs for which they were not easily accessible. That's a bigger problem, but also require pulling together specification by looking at 5 different locations. Some of it is not understood, and the designers and engineers who designed the chip have moved on. There is no way to figure out what the entire thing means, and we have test suites that were like years old that we were running. It's regressions, but there was no documentation associated with the test either. So it was a very bad situation where we will find bugs late in the design, but there was no way to close the coverage. So the clear case for a good documentation, and I think the amount spent on documentation pays off because the coding speed just goes up dramatically if there is a clarity on the design itself. And sometimes you will have experimental things, you will explore architecture, you would not know precisely what you're going to do. So you will go through the cycle of designing something, trying, experimenting, simulation, and then redefining it, which is perfectly okay. But in general, it's a problem if it's not adequately addressed. So algorithms, either the performance or power issues were there. There were inefficient or bad configurations that had to be changed. Again, poor phrasing, misunderstood by engineers and designers. We had a situation where engineer was communicating in a meeting what the spec was. It was not written down clearly. And she didn't have time, or he didn't have time to do it. And the response was, I mean, I'm not responsible for verifying that's not written. Verification, you can't outsource something. Try doing some work with the Department of Defense. Everything has to be spelled out in a way you have no other way out. So the schedule pressure is kind of a false argument, because at the end of the day, it does save schedule. And if you find a bug in the customer, it's a much bigger issue. But otherwise also, even on that particular project, it's going to be much bigger. Implementation, this is, everybody understands it. We do find every now and then some issue that's related with the implementation, but more often the bugs that escape, that are harder bugs, you can correlate to a lack of documentation somewhere along the line. So it's a legacy code mismatch with architecture. Now, one of the things that happens these days a lot is we are always reusing a big chunk of code from the previous design to the new design, except with a minor modification. Suddenly, you don't have the documentation of the previous design, which is complex, and minor modifications, implications, you cannot understand unless you can go and read the documentation of the previous design. The problem with the previous design is that that designer is gone. You have no access to figure out what that design does other than reverse engineering the design itself. And that's a big problem. So inadequate design spec or mismatch on the legacy is a huge issue. And this is, again, this is a verification engineer responsibility. We want to be able to, point number 5, traceability to spec. Somehow your coverage plan, your verification plan should identify every possible things that are on the spec that you need to verify. You can consciously choose not to verify it. You can deprioritize it if you're time constrained, if it's okay to do so. But inadvertently, you should not miss out on something that is important. So the prioritization may be required, but you should have some level of traceability. Now, a lot of tools are available for this. But even if you don't have a tool, rigorous reviews can pinpoint you the correlation between spec and your actual verification plan. And if that's missing, you can miss out. You can get a false confidence and so on. Enumerated test templates are one way of tracking things people do it, and that's an important one. But other one, rest of things, yes, go ahead. Okay, no problem. The coverage plan, again, so part of it's like verification universe is very large, and you can't ever do complete 100% simulation. Some parts of design is formal verification, but formal is not quite scalable to the complexity of design today. So you pick and choose your battles and do some things. However, so that when you do pseudo-random, that's again, you have to constrain. So the coverage is very critical, but the problem is coverage plan is you can have a gap in coverage plan and not have adequate and proper coverage, because part of that planning again requires rigorous documentation. And it requires working with people who have worked on the design, design engineers, and sometimes teams from other things. So any gap in coverage can give you false confidence that you have finished the project. Reviews are very critical for, and this is a very important slide in the sense that when we plan the project reviews, you will be sitting on the review of some other person's designer team. Your time has not accounted for in the project planning that you will be spending 10% of time or 20% of time doing review for somebody else's design. Now, this is the true for everybody. So this is all a side activity for you. And same for everybody else who's sitting in your reviews. So their time needs to be accounted for in the project management. Without that, when sometimes we rush through the reviews, not proper reviews, rush through it, and there are gaps in there. And the priority is the person, your priority is something else versus sitting on somebody else's review. So that has to be something, has to be addressed by the project team and project management. And the last point just highlights that we haven't planned properly. So that's a big thing. So finally, the takeaways here is verification is a written contract. You are only responsible for verifying what's written in the specification. You cannot verify that's in somebody's head. Although unexpected stuff is there. It's just a point of argument I'm giving you only because this is a problem in every verification team, because everyone is rushed for schedule and they are taking shortcuts with the documentation. So any gaps in documents is a gaps in verification because you thought you did 100% planning, but the spec itself was somehow less complete. So ROI, improved quality, maintenance is easy, of course, as we talked about. Improved schedule, and future proofing is another big thing. If you heard Adnan's presentation or Impera's presentation, Larry's presentation, or any of these new technologies, I've been playing a lot with ChatGPT+. The power of it in verification stimulus generation is immense. So that's something can rely only the prompt engineering. You have to define your prompts in a careful way. Is coming directly from the spec. So the well documented your spec is, more ready you are to adopt new technologies. And especially as you move to the derivative designs, they all leverage your previous documentation. So very critical to have some kind of rigor or a discipline or a format discipline about your documentation to make your things future-proof. Thank you. Any questions or any comments? Observation? Go ahead.
I'll just grab you a mic, sorry. So people online can hear me. That's,
By the way, my glasses are not Google glasses. I was just trying to make a point.
Just tell who you are, Bill. Yeah.
Hello? Hello?
Yeah, we can hear you, Bill.
So your talk reminded me of the first 5 minutes of my first day in Engineering 101. The professor said, first state the problem, then work on the solution.
Yes.
And, you know, my observation over the years is that most students who are not yet.
We all start at step 2, not at step 1.
So thank you.
Thank you.
Any other
comments?
Okay, then, sorry. Just grab the mic, introduce yourself.
Yeah. Well, again, my name is Vladimir Mello. I work with Intel. And thanks so much for your presentation. I think you, as well as a couple of other folks here, touched very important things in terms of methodologies, right? When we talk about documentation, we are talking about a methodology, a process.
Yes.
And it seems like we are being very good on developing process and tools flows, but we are forgetting to establish and create a human flow and design from the perspective of the engineers and the human beings there.
Yes.
Right? So on top of everything that you said there, which I agree and sign off on it 100%, I want to mention also the dynamics with which we deal nowadays in terms of design, because whenever we have architectural folks driving their architecture as per product demands or specs or marketing demands, we are already having our designers working on designing those specs and bringing alive previous IPs. So the reusability of IPs creates a problem, because sometimes we reuse IPs with a restricted number of functionalities, and down the road, verification, validation people are going to be validating stuff that we don't need anymore.
Yes.
And that's another waste of time.
Thank you.
Thank you. Thank you. So just quickly before we finish, there's as I said, there's a few spare of these if you want to grab one. After the break, we're back in here for the main track. We have another training session from Doulos in C and VHDL verification from Jim Lewis in D. Okay, and you'll get a feedback form. Please fill them in. We do listen and we do try and improve things for next year. Okay, thank you.